topic. Before that, let me tell you that what is the topic is and what is based on. Okay. I hope you people all know the figures, right? In our day-to-day life, what are all the structures we have? Okay, and we have geometrical structures of it. But what is an mathematical equation of it? Mathematical formula, and that is what we are going to discuss today. And simply, let me give an example for you. If you see an arch, what shape is this? Okay, it looks like a semicircle. Or else you can say something else. Parabola. Right? So it just looks like a parabola. So it is an arch, or else you can go ahead with a curve. So like that you can imagine, but it is a parabolic structure according to mathematics. Right? Similarly, let me give an example. It looks like an ellipse. It is an ellipse. In a coordinate axis, which means the x and the y axis, the structure is given to be like this. You may say this is an arc and this is the other arc, and this constitutes an hyperbola. The structure of this is said to be an hyperbola. We know the geometrical name of it, but we need to define its formula, that is the mathematical formula. For example, I have given a parabolic structure here. So I will be giving an equation for this is said to be y square is equals to 4ax. Is that clear? And also for an ellipse. For ellipse I can given the coordinate axis. And we got shape is an elliptical shape, but it is horizontal with respect to x axis, right? So with respect to x axis, it is an horizontal ellipse. Okay. So let me give this as an equation as x square by a square plus y square by b square equals. Okay, this is an equation of this. And if I go for hyperbola, the equation of this is, can be given as x square by a square minus y square by b square equals to 1. So just I have introduced these structures only for the equations. Okay, so we have the structures in day-to-day life. We used to see these structures. Right? So this is an elliptical shape, and this is a parabolic shape, and this is a hyperbolic. These things are all we know for us. But in mathematics, how we denote the things? Okay. So in that only we have, according to the polynomial, we have a relation that the relation between the geometrical figure and the algebraic equation. Before that, you know what is algebra? What is an algebra? It is nothing but this gives the relation between variables and so here I have an equation for a parabola, that is y square equals to 4ax. Here the constant 4 is involved and the variable x, y and all involved, right? So and this is what the algebra states. Okay. So with respect to this algebra, we have polynomial, and which is said to be a polynomial is nothing but the power of a polynomial should be of a whole number, then it is said to be polynomial in terms of an algebra. Okay, in algebra, we will be having an equation x square plus y power minus 1 plus 1 equals to 0. Okay, so I can state this as an algebraic expression. I cannot state this as polynomial. Why? Because for a polynomial, the degree should be of a whole number. Okay, but here the degree is of the inverse term. So we cannot state this as an polynomial. It is simply said to be as an algebraic expression. Okay, so by my topic is of, how I come to the topic, my topic is of linear equation. So, linear equation in the sense we have learned in our previous sessions that is in our lower class. Equation in single variable and types of polynomials. From 8th standard you would have come across. So here, let me go at the pair of linear equation. So in a pair of linear equation, in the sense we are not going into this polynomial, I mean the degree and those things and all. Okay. So here we should represent the degree of linear equation should be 1. Okay, the degree of a linear equation should be 1. So therefore the linear equation can be generally expressed as ax plus by plus c equals to 0. And this is the general form of a linear equation. Okay, so here it is in two variables. The linear equation in two variables. So I have given an equation ax plus by plus c equals to 0. Here the variables are said to be x and y. So here x and y are the variables, and a, b, c are said to be constants. So simply I can give an example as 2x plus 3y plus 1 equals to 0. Simply an equation 2x plus 3y plus 1 is equals to 0, and this is the general form of a linear polynomial and an example of it. Okay, and here in this chapter we are going to discuss pair of linear equations. We need to solve it. A pair of linear equations means two equations, right? So the two equations, let me assume that as a1x plus b1y plus c1 is equals to 0. Then a2x plus b2y plus c2 equals to 0. Okay. So and these two are said to be the two equations in two variables. We can solve this by, so one is by substitution and the other is by elimination, and the next is by cross multiplication. So before that, with respect to the equation itself, we can state how the solution will be. So I have here an equation a1x plus b1y plus c1 equals to 0. Then a2x plus b2y plus c2 equals to 0. So with respect to the constants here has to be a1, b1, c1, a2, b2, c2, I can express how many solutions it can have. Okay. So let me have the ratios of this to be a1 by a2. Then b1 by b2. So if the ratios, that is a1 by a2, if it is not equal to b1 by b2, then I can state it has unique solution. So with respect to the coefficients of xy and the constant, I can state how many solutions it can have. So here I have the x as, I mean the coefficient of x1 of a1, and here it is a2, and here it is b1 and b2. If the ratio a1 by a2 is not equal to b1 by b2, then I can state that as a unique solution. Therefore, the system has unique solution. If I have a1 by a2 is equals to b1 by b2 is equals to c1 by c2. If all the three ratios are said to be equal, then I can say that as an infinitely many solution. And the next, a1 by a2 is equals to b1 by b2. So if people may have doubt, so here a1 by a2 is not equal to b1 by b2. By the first condition itself, you can say if it is not equal, it has unique solution. Here all the three are equal, so you can state it as a unique solution, infinitely many solution. But here in the case, a1 by a2 is equals to b1 by b2. The ratio is said to be equal, so that you can come to the conclusion that it has infinitely many solution. But you have one more option, that is to be equal to or not equal to c1 by c2. If it is equal to, it is obviously infinitely many solution. But if it is not equal, it has no solution. Is there any doubt? Hope you people can understand. Here we have the two equation in two variables, and the coefficient of x as a1 and y as b1 in the first, and here it has a2, b2 and c1 and c2 are constants respectively. Then let us take the ratios of it as a1, a2, and the other ratio is b1, b2, and the other ratio is c1, c2. So in the first condition itself, if we go into the a1, a2, v1 by v2, then it is obvious it has unique solution. Okay, and let me conclude you later what is unique solution, infinitely many solution, and no solution. And then the next you have a1 by a2 is equals to b1 by b2, and it is equal to c1 by c2 also. Then it has infinitely many solutions. Then the first two ratios are said to be equal, and the last one is unequal. Then it has no solution. Is that clear? Okay. So with respect to this, in a graphical method also we can state how the solution exists. So here a1 by a2 is equals to b1 by b2. Sorry, it's not equal to b1 by b2. So we say that it has unique solution. So unique solution in the sense that two equations if we solve by the three methods, one is by substitution, elimination, and is by cross multiplication, we will be getting only one point, right? One is x value and the other is y value. So if we solve those two equations, obviously I will get a point, okay, which is said to be my x and y, is said to be a point. A point should be represented only within the bracket. If it doesn't represent within the bracket, then it is said to be direction cosines in your higher class. Okay, that is DCS we will be representing. That has to be DCS, and a point always should be represented within the bracket, right? So here x and y will be applied by using those three, either of the methods. Okay, so we will be applying x and y, and this is nothing but a point alone. Okay, so that point, only one point will be applied when it has unique solution. Okay, which means in a graph, before that I need to introduce you that a linear equation is nothing but the graph is faced by this straight line, right? And that is the very most important thing. I have told you anything that the power 2, I have given many examples in beginning, that is x power 2 like that above. Okay, so x power 2, that is the degree 2 stands for a parabolic equation or a circle, whatever it may be, and for a degree 1 it stays only a straight line. So you may ask, only the straight line will be of this type. We cannot state the straight line to be of this. This is also said to be a straight line. Okay, so a straight line is nothing but the equation of a linear is said to be obtaining the points at a different way. So it may be the point may be here, the x comma y may be here or here or here. So the traces the straight line in this part. We cannot state a straight line only will be on this shape. We cannot state this as a lot of straight line. Obviously, in physics also you would have learned a straight line cannot be half the rectilinear path cannot be same like that. So it may traces like this also. So here for a unique solution, I am going into the graphical method. I need to apply a point over there by solving those two equations a1x plus b1y plus c1 equals to 0, and then the similar one. Okay, I will be applying a point x comma y. Okay, so how? Again, I have told you that the linear equation faces a straight line. So simply for an understanding, I will give a first equation, that is a1x plus b1y plus c1 is equals to 0 to be of this one. Let me give that as L1. Okay, and then the other line a2x plus b2y plus c2 is equals to 0. That is said to be the other equation. That is also tracing a straight line. I am giving the line has to be like this. These two lines are how it looks like. Don't say simply as x or something. They are intersecting. Right? So we can state those two lines L1 and L2 are intersecting. Okay. So if we need to get unique solution, the two lines are said to be intersecting. So please keep it in mind, if you need to get a unique solution in a graphical way, it should be of intersecting. Is that clear? So then we have infinitely many solutions. So can you give any example, or else can you state anything how you will be getting an infinitely many solution? If it is parallel, there will be no solution. More intersecting points. Intersecting in the sense it will be intersecting at only one point.
They are same.
There will be coincidence. Okay. So let me have a coordinate axis here. So here I have a1x plus b1y plus c1 is equals to 0, and the next a2x plus b2y plus c2 is equal to 0. And that is the standard equation for for a linear equation in two variables. I am giving the same example, right? So none other than that, we can have an example here. So let me have the equation for the first one. Here it is somewhat different case, and here I am giving for the equation as L1, and it is to be of limits, right? And for the next equation, a2x plus b2y plus c2 is equals to 0. That also lies on the same line, which coincides on the L1 itself. Is that clear? So here I can state that, but in the previous condition I can have only one point since they are intersecting. So only one solution I can have. That only one solution is said to be unique solution. And here the same lines, the lines intersects or overlapping, or if they are coincident, whatever. Okay. If we say like that, here in each and every point we have different solutions. Can you able to understand that? So here it may be x1 comma y1, x2 comma y2. So it may extend. Okay. So in such a way, if they are coincide, we will be having infinitely many solutions. Is there any doubt? So the next, the same coordinate axis x and y, the same equation, the linear equation in two variables. The first equation a1x plus b1y plus c1 is equals to 0. Traces a line in this manner, and the next one traces a line in this manner. How does it look like? It's said to be parallel. Is there any coincidence, or is there any intersection part? No. So they are all separate parts. Okay. So by that means, what can I state? It has no solution. No solution. By that means they are parallel. Clear? So let us go ahead with certain examples for substitution, elimination and cross multiplication. Before that, let me give you the cross multiplication in general form. Why? Because for substitution and elimination, you can find for substitution, you can get either of the value. Either it may be x value or it may be y value. Then you will be substituting in either of the solution. Either it may be x value or y value. Is that right? And for elimination, you will be eliminating either x or y. Okay. But in cross multiplication, since that is divided in our syllabus, just I am taking note. So in our cross multiplication method, just how we will be taking the equation. So here I have a1x plus b1y plus c equals, and c1 equals to 0, then a2x plus b2y plus c2 is equals to 0, the two equation. So I need of the variables here x, y, and the constant, let us mention that to be as 1. And here the procedure follows the same. So what is the coefficient of y here? b1. So here the condition is you should start with the coefficient of y, constant. Again you should come with the coefficient of x, then y coefficient. Is that clear? So start with y, constant, x, then y. Is that clear? So tell me the coefficient of y here in the first equation. b1, then constant, c1, then the coefficient of x, a1, then what is our coefficient of y, b1. Is that okay? If you write this in the correct manner, since you will be putting suffix in here, that is b2, c2, a2, again b. Is that clear? So once again I will repeat for a cross multiplication method. You will start with the coefficient of y, constant, coefficient of x, again you will end with the coefficient of y. Right? So b1, c1, a1 and again b1. And here simply we write b2, c2, a2 and again b2. So here you need to find the x and y value, right? So the main concept is to find the pair of linear equation is to find the two values x and y. Okay, that is very most important. So we have assumed here y and x, y and the constant one is b here. Okay. So the procedure is first x divided by, just you simply write the procedure follows as the same. X divided by something that is equals to y divided by let it be, and that is equals to what is the term here? 1. That is maybe a constant. You can place there as k and at last you can remove also. I have placed I will be proceeding later. Okay. So here you have written. So is there any confusion in this pattern that what you are writing? So you will be starting with y coefficient, constant, x coefficient, y coefficient. Then here also the same, just you will be replacing the suffix by 2. Okay. So the first step is just you keep it in mind that you will be multiplying the numbers which is in above with below. Okay. Put an arrow mark like this. So B1 with C2, C1 with A2, then A1 with B2. Is that clear? So in simple, you can see to the below. Is that clear? Okay. So B1 C2, just multiply that B1 C2. Then again C1 B1 C2, right? C1 A2. Then A1 B2. Is that read out? So the next step is B2 C1, just subtract it. Minus C2 A1. Then A2. Is there any doubt? So the first thing you will be writing the coefficients. I hope that is clear for you. The next, the first one, that is the place with the upper part will be multiplied with the second part in the second place. And similarly C1 with A2, then A1 with B2. I hope you can understand the arrow mark that I have placed there. So that will be written at the first. Then you will be making it negative. Then B2 C1, C2 A1, A2 B2. That will be subtracted. Okay. Now you get the value of x, y. Is that clear? That is the main concept. We need to find the point x and y. So since I have variables, you may think that it is not difficult, but the general concept is okay. So here, what is this now? We will be having x by something. Okay, that should be equated to constant. Is that clear? So you will be equating the x with the constant to get x value. So here, x by b1 c2 minus b2 c1, which is equals to 1 by a1 b2 minus a2 b1. So the next step is you will be taking to the other side and it will be multiplied with the numerator. So that is x is equals to b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. And this is what your x value. Simply you will be having, let me give you x by 2 is equals to 1 by 4. If it is like this, if x by, I have b1 c2 minus b2 c1, right? In place of this equation, if I have a number that is a constant, this simply has to, and by 1 by something has to be 4. So I can take the value as x is equals to 2 by 4, which is equals to 1 by 2. So therefore I will get my x value as 1 by 2. Similarly, I can have y by something that is equals to the constant. I will be equating. So y equals to, if I will be multiplying to the numerator here, c1 a2 minus c2 a1 divided by a1 b2 minus a2 b1. And this is what my y value. So at last I have applied the solution of x and y. Is that clear? Similarly, I can go ahead with the same. So if this remains to be the same, this cannot be changed. For an example, I have given you x by 2 equals to 1 by 4. This 1 by 4 cannot change. But in the place of the equation a2 minus c2 a1, I can have some other number as to be 6. For example, if I have 6 here, y by 6 is equals to 1 by 4. Right? This constant term remains to be the same. It cannot be changed. For this example, it cannot be changed. I can give some other example. So y is equals to, if I take the 6 to the other side, 6 by 4 into table if we cancel 3 by 2. So my solution will be 1 by 2 3 by 2. And this is for the solution for this example. If I take this as an example, the solution is 1 by 2 3 by 2. And here I have derived the general form of it. Is that clear? So and then you should remember that in an ordered way, that is to write the solution of x and y, that is as a point x comma y. We will be writing that as an x comma y. So here the variable is x and y, I will be writing as x comma y. If the variable is p, q, then I will be writing as p comma q. So first of all, you should write your x coordinate as the first and y coordinate in the second. In your lower class, that is in your 9th standard, you would have learned that the other name of x coordinate is akshasa and the other name of y coordinate is ordinate. Also, you will remember for the students. And y coordinate that is ordinate, simply ordinate. Is that clear? me give certain examples for that pair of linear equations to be represented graphically and also algebraically. That is a unique solution, infinitely many solution, or no solution. So let us have this as an example. So x minus 2y equals to 0 and the other as 3x plus 4y minus 20 equals to 0. Compare this with the above equation. What can you state in the sense? Here simply x is present, which means the coefficient of x is said to be 1. Is that clear? So the next is the coefficient of y is b1. Here it is minus 2. We should take the sign. And whether the constant term is present here? No. So the constant c1 is not present. So it is simply 0. And here in the second equation, a2 value is 3, b2 value is 4, and your c2 value is say with sign as b minus 20. Okay. Now you will be checking it whether it is unique solution, infinitely many solution, or no solution, or else whether it will be intersecting, coincidence, or no solution. I mean parallel. Okay. So just we will be writing a1 by a2. So what is the answer for a1? That is 1. 1 by 3. And a2. Sorry. b1 by b2. Here our b1 value is minus 2 and my b2 value is, so that is minus 2 by 4, that is minus 1 by 2. So it is obvious that within the first step itself I can conclude that a1 by a2 is not equal to b1 by b2. So that what can I state? That's unique solution. And also in graphical I can state it has intersecting lines. Is it clear? Sorry, is it clear for you?